I'd like to welcome everyone to the webinar series of the Cybersecurity and Information Systems Information Analysis Center, CSIAC. Today's presentation is entitled, What is DevOps? From a Tools Point of View. My name is Steve Warzala. I'm the CSIAC Outreach Manager. A few administrative notes before we begin. First, all phones have been muted except for the presenters. Questions may be asked at any time during the presentation by utilizing the chat function. Time permitting, your questions will be answered at the end of the session. Today's briefing slides will be posted on our website within a few days. Finally, I'd like to take a moment to acknowledge and thank our sponsor, the Defense Technical Information Center, DTIC. Funding that DTIC provides enables CSIAC to conduct these webinars. It's my pleasure to introduce our presenter for today's webinar, Mr. Mike Corley. Mike is a Research and Development Associate of Quantarian Solutions Incorporated. He's involved in various advanced technology development efforts supporting DTIC, CSIAC, and the Air Force Research Laboratory in Rome, New York. Corley has 20 years of professional experience in software architecture design, software development, and systems engineering, focusing on applications of computer networking and cybersecurity. He received his master's degree in computer engineering from Syracuse University. And Mike's recent research interests have been involved in exploring the utilization of next-generation cloud-enabled services. I will now turn the presentation over to Mr. Corley. Good afternoon, Mike. The floor is now yours.
Good afternoon. Good afternoon, Steve, and thank you for that introduction. So I do have one question for you, Steve, since we're on the air here. I don't see, there we go, I got it. Thank you. I didn't see the means for advancing the slides, and I've got it. So good afternoon, everybody. Thank you for that little bit of patience there as my colleagues were working out some of the technical difficulties. I hope most folks are having lunch. This is a perfect time to enjoy a webinar and have lunch. But just before I begin, I'd like to say that, give you a little explanation for the title and what I think that there's value in talking about. In talking with folks in the community, there's still a lot of confusion or a lot of question about what DevOps is, how it relates to Agile or how it relates to the software development lifecycle. And it's often thought that it is centered on a particular set of tools or a prescribed set of tools. And interestingly enough, there's an explosion of tools out there today, and as you sift through them, it can become overwhelming to people to see where some of these ideas fit, various applications or cloud infrastructures. And we've had discussions about this at QSI amongst ourselves and with folks, and some of those discussions we said, hey, this is valuable. Well, let's capture some of this discussion that we've had and make it presentable in a way that we can share it with the community. And that's really principally what motivated this talk. So what you'll hear in here is largely our perspective, my perspective. There isn't necessarily a right or a wrong way or a set of prescribed tools, but let's dig in. It's about really giving some thought to the DevOps principles and thinking about how to apply your organizational business needs to those principles in order to achieve what you're looking to achieve, better, more efficient software practices, et cetera. So with that, I said too much. Let's just move on. So what we're going to talk about is, as I mentioned, a little bit about DevOps, and then once we lay the foundation to that, let's talk about just some technology enablers. Container technology is a big deal, a little bit of how that relates to the cloud, and a little bit about some of the newer software development environments that I played with, particularly some of the .NET. I come from a .NET technology, from a managed, a lot of people are either Java or .NET folks, and I still do an awful lot of C++ development, but I like the managed environments and I like .NET. I grew up with .NET and I'm very interested in .NET Core and how it maps onto some of these things. So I hope to share a perspective on some of that as well. But to dig in, if anybody hasn't heard of DevOps, I'm sure most people listening have, it's a portmanteau for the phrase development and operations, or a putting together of those two ideas. And what it really is, more than anything else, is it's a culture and a set of processes with the specific objective to make or achieve a better efficiency in what we're all aware of as the software development lifecycle, all the phases of that. For a long time, as a lot of people know, the model was the waterfall model, where you design the system and you follow the various phases where you can't get to the next phase until the previous phase is complete. A very linear process the waterfall model was, and God forbid you would have to change something at a later point in the phase. You can't. It's very rigid, very hard to change, and that's what really led to the agile idea of smaller incremental software development, focusing more on collaboration and customer feedback, because customer feedback is just fabulous domain expertise. It's invaluable. And a smart person once told me the only thing that we're guaranteed not to change is change itself. So Agile is really about this notion of accommodating constant change, where the linear model, waterfall model couldn't handle that. The Agile model the Agile Manifesto made some great gains in overcoming some of the limitations there. But they discovered, it's been a discovery and an ongoing discovery, that there's problems that arise within that as well. And one of them is the communication between people. There are people involved, and it turns out that in between groups of teams within an organization, you have an iterative thing happening, but you don't have the communication. You don't have that cohesiveness within an organization. And that's really what DevOps is all about. It's about it's really an extension of Agile ideas, but to an entire organization. So you see the phrase DevOps, meaning development and operations folks working together, breaking down those silos, but it's really organizational wide. It's not limited to a specific team. It involves testers. It involves everybody who's involved in the product development lifecycle. It involves management. It involves customers. So it's an organizational movement and a culture more than anything else. So, and who's investing in it? Well, everybody's investing in it. You can't really surf the web or talk to anybody today and focus on sets of tools without seeing that term pop up. So with that, let's see if we can't extend a little bit more into this. So, main ideas, I hit on those a little bit for why to use DevOps. It really grew out of the disconnects that naturally arise between people. Within an organization, you have miscommunication, misaligned goals, and you have different people have different ideas and objectives, different levels of technical competency. And what these do is they manifest as conflict and inefficiency. And the larger the organization is, naturally, the more complex it becomes. The larger development team, 50 people on a development team can't all talk to each other at the same time and convey ideas. There has to be tooling, there has to be process, there has to be, later on I'll talk about this idea of environment parity and process parity, and hopefully there'll be some part of the goal here is to maybe spark some ideas for folks that are listening to continue on and have maybe some different outlooks or different perspectives on some of this. But, approaches to overcome some of the problems of communication amongst groups, collaboration, and integration between software development and information technology personnel. That was the big thing. And really, like I mentioned earlier, it's about breaking down those bottlenecks or those silos that lead to this conflict and inefficiency. So here's the idea. It's a cultural movement, as we said. There's different people working in different roles, and there's the mentality of, well, that's not my job, so I won't pay attention to it. And then there's the flip side of that. Well, that is my job, and there's the stepping on toes idea, this ownership ideology, if you will. But what DevOps looks to do is it looks to just overlay that or throw out that culture with this idea of everybody in the organization becomes, or everybody at least within the product development lifecycle, the path, becomes a first-class citizen. So you certainly do have, in a general case where you might not have security folks involved in software development processes, they might be more involved traditionally in the deployment or the maintenance side of it. This says no. Everybody is a first-class citizen, and everybody's involved in all phases where it makes sense. And this is where we do a better job of breaking down some of those bottlenecks. So you see the contrast of the silos on the left and the the classical DevOps icon figure on the right, where everybody's iterating together as one cohesive unit. And the interesting thing is where tools come into play and how they help to enforce or enable this kind of working together. So, there's some principles. When you start to break down or classify what DevOps is and how to map tools and ideas into it, there is an ongoing community-wide focus on this evolution of what are the principles, what are the tenets. And what you see here, these 4 tenets that I've got listed: collaboration, infrastructure as code, automation, and monitoring. Those are kind of the big 4. And I really got these, when I got interested in this a couple of years ago. This is kind of spearheaded, led by the folks out at the Software Engineering Institute out at Carnegie Mellon. There's a bunch of smart folks out there, and a lot of people got involved. References to some of that later on that you can take a look at. But these are evolving, but if you follow these, you can see kind of how, when you're thinking about DevOps, how does your organization map onto these tenets? And then when you're looking at various tools, there are an explosion of tools. How do they map into these? How do they implement, or how do they support some of these tenets? So collaboration is a big one. Getting folks to talk to each other and a means that they can understand, and tools that will help with that. Lots of them. We've used Slack. It's more of a channel-based, or I think another one's Rocket Chat. We use that one at home. And you get this channel-based kind of thing where you can have lots of folks subscribing to a channel, and you can very quickly get information back and forth. You've got 50 people, you can break the communication into different channels. And then let's say you've got a rendering team that's building some software that needs to get information about a team that's building a parser, a DOM parser or something. You can very quickly message back and forth and share information. Jira and Asana, I've not used them, but you can look those up. They're also very popular and very good for, Jira is very good for collaboration and management. There's a lot of them. So, as you look at these kinds of tools, think about these principles. Information as code is a very interesting one. This idea that you can script or formalize as code now entire environments. That's nodes and networks and configuration management and all the runtime environments that make up complex environments, making them repeatable and portable. It's something that is central to this idea of establishing environment parity, as we'll see. So what developers develop against is very consistent with what the system runs in a production environment, as an example. And we'll talk more about that. If I don't talk quickly, I might not get through everything I want to say. So automation is a big one. How do we automate process? It's really about automating process, continuous integration, build artifacts, and how do you get those into the various environments? And there's very good tooling out there. I just listed a few of them. Jenkins is a very popular one. There are tools that are in the cloud, AWS and Azure, and I'm going to talk a little bit about Docker and containers because those are that's an interesting beast that I think that a number of folks have some confusion on. So we'll talk about that. And there's others. And then lastly, monitoring. You have to know. It's about reasoning and about knowing that that the things are working the way they should be working. Is the system performing the right way? Are the users consuming it as it's intended to be consumed? And there are some tools for doing that. However, it does get complex when you're looking at an infrastructure as a service that is providing a container environment. You end up with these abstraction or service boundaries that can be very hard to see across those boundaries in some cases because you can't see across them. I mean, it gets back to the original idea that abstraction is wonderful. The good news is it hides you from details. The bad news is it hides you from details. So there's definitely these trade-offs between all of these things that we can do and having our ability to have the right visibility and the ability to make, especially in a world today where security is a big deal. How do we make guarantees? How do we know what's going on? So there are definitely forces. I'm not saying in any sense that these are silver bulleted ideas and you go do these. No, these are just really interesting ideas that propel us forward and help us to make progress. So keep that in mind. It's good stuff. Okay, so just a very brief recap. We talked about collaboration, this idea of communication and processes within disparate roles. Scripting as much as possible, the various environments, testing environment, production environments, development environments. Developers build code in an environment that's unlike the production environment. So when you go to take something to production, all of a sudden it doesn't work. Perhaps because they opened protocols, they're using ports in their development that haven't been vetted by the security folks. So there's an issue, an example of some of the communication breakdowns, and that's costs money, it costs time, it's inefficient. So how do we do a better job with that? Infrastructure as code helps with that a lot because it takes everybody in the path of the product development lifecycle to provision these. I'm going to show you some examples. These scripted infrastructure definitions that ultimately end up managing or providing virtualized infrastructure. It's quite an interesting thing. Automation, this idea of removing as much of the menial, error-prone, human error-prone kinds of things as possible. It doesn't mean that you replace smart people. It means that you automate to assist. You take out the things that are scriptable or the things that don't require behind-the-eyes thought, and you look to make those uniform. The DevOps keyword is environment, or I should say process parity. Achieving that idea of making things automatable or uniform. And again, we talked about monitoring. So with that, okay. So the things that you tend to hear about that map onto these, continuous integration, this idea of standardizing the submission process, getting the different software components that are intended to work together into the various environments. A mock production environment, a testing environment for quality assurance, development environments, and the idea there, and there's tooling to do that, lots of it. There's configuration management systems and build servers, and we'll talk a little bit about that. But everybody gets visibility when you achieve some of this uniformity. Everybody gets notified sooner. When you can do a better job at integration and delivery, you can fail faster and you can fix faster. So same idea. The idea of continuous delivery is getting software into the hands of the customer to get feedback as soon as possible, or perhaps into a mock staging environment where you're simulating that idea. Continuous deployment is something where you really are pushing code out into the production environment where it's being consumed by the intended users. That's not necessarily something that is desirable by all domains. It really depends on the domain. Some competitive environments, you want to get your system out there as quickly as possible with the guarantees that you haven't introduced new security vulnerabilities and things of that nature. That's what's considered there. And the takeaway here is the goal is process parity, that uniformity or automating the way you get things into the environments, and then environment parity. The environments themselves have to be reproducible, have to be consistent. And that's how you achieve this idea of regular testing or constant delivery. So just as Agile is concerned with managing constant change, DevOps takes it one step further and says we're going to provide regular constant test, constant delivery. It's that one step further. So when you get into tooling, you have to give some thought into the software development lifecycle, and those categories you see there. You see different variations on it: requirements, code, build, test. This is one instance of it. But what you do is you look at how the SLDC maps on the tools that fit those categories, map onto those various tenets that we looked at before. Is it about collaboration? Is it about infrastructure as code? And how do these fit the various stages? And it provides a good, taxonomy or organizational method for understanding what tools fit where when you're first beginning and thinking about how do you build a DevOps pipeline so you can achieve continuous integration and things of that nature. It helps you to sort some of this out because so many tools out there, I'm going to show you in a minute, with so many different overlapping features, and it is overwhelming. It was overwhelming for us. It's still overwhelming for us. And that's some of the conversation that we've had that's led to some of this discussion. But the big thing is it's not constrained to a set of tools. There's a lot of tools, and there's a lot of ways to be successful. It's not so much about the tool as it is thinking about the principles and how they map onto your organization and your organization's needs. So here's one example that I liked. Jenkins is an automation. I've not used Jenkins myself, not yet. I've used a number of different tools, but it's an automation server that's highly, highly pluggable. So what you find is it's a nice conduit for building this rich ecosystem. So if you look at the various phases of the SLBC, in this case, you see code and commit, you see the building and configuring, testing and deployment, and you see how all these different tools in here, some of which I've mentioned, Visual Studio and Eclipse are IDEs for building code. Git is a distributed artifacts repository for managing the builds and such. Maven and Visual Studio appears over here in Build and Config as an IDE. It's responsible for building and configuring. Docker fits into a couple of different categories. So these tools, as you see, they definitely map on to different categories because of the overlap and the richness. But the idea is how well do they fit into this ecosystem, and where do they fit? How can I make the gazintas of one fit into the gazintas of the next in forming a pipeline? And lots of tools for that. So here's another example. This one starts off, this is collaboration, build, test. This is more DevOps centric, but you can see where some of these tools fit in here. And I won't elaborate, but Docker's in there and some of the container kinds of things. So if anything, I'm sure a lot of folks are familiar with a lot of these tools, but you can go back and you can give some thought to some that you might not have heard of, or some that you're interested in taking a deeper look at. So one of the biggest issues with DevOps and making it work is the realization that it's a cultural movement. An entire organization really has to be willing to conform to change in order for this to work. That's been one of the biggest pushbacks and one of the biggest discussions in the community right now. I've got a couple of links. The one at the bottom, this is an older link, but you can usually go to the site and get some information about what's latest. These guys did a very nice one-day course or seminar on, they hit on a lot of these things, and that's what I drew a lot of my initial observations about DevOps from the guys out at SCI in this case. But how well do people work together? How do they view their relationships with their peers and managing? That's really the big factor in terms of how well it can be adopted. Those are the big bottlenecks. Security is a major topic, and it's a discussion all on its own. And I'm not going to talk specifically about security, but when you're looking around, you'll see terms. There's a number of terms that describe how it relates to DevOps, DevSecOps, Secure DevOps, and it's really about how you integrate security at all this. How do you overlay that on all the stages of the SLBC? So again, a whole topic of its own, and they do a really nice job. The guys at Carnegie Mellon really focused on that, actually, Secure DevOps Process Implementation. I recommend that one. That's the one that I liked of all the things that I had looked at. Okay. So given what we had just said, I want to look at some technologies that are centric to that. I want to look at a little bit at virtualization. A lot of the cloud environments are really based on the virtualization idea. Containers and this idea of microservices. Microservices are not necessarily containers. They are microservices are really an iteration on, or extension of, if you will, service-oriented ideas, service-oriented architectures, where you have cooperative services, applications as cooperative services that tend to be very lightweight, fine-grained, and reproducible, and containers are a great fit for that. So you do see containerization used in tandem with microservices. Some of the .NET implementations, specifically the .NET Core, is very interesting to me and how it fits some of these ideas. So I wanted to talk about that. And there's some componentry to that I thought was relevant. And Xamarin is interesting. People have different thoughts and ideas about what it is, and I'll share a little bit about that. That one isn't so centric to DevOps, but it's part of the family, so I wanted to mention it. The .NET Standard certainly is interesting. And NuGet is a package manager that is designed to work with Azure DevOps, and it's foundational to the .NET Core component in terms of how it works. So for anybody that's interested or hasn't looked into that, I think there's a lot, even if you're not a .NET person, architecturally, there's a lot of neat ideas to take away from it. So I thought it was relevant, so we'll talk about it if we have time. Okay, so to begin, what's a container? Well, containers are really isolated applications that run in the kernel, directly in the operating system kernel. There's no hypervisor. There's no guest operating system as you would experience with a virtual machine. They're isolated applications that run in the context of the kernel in isolation using kernel features, like the kernel namespaces and control groups, which are used to control how much resources are allocated to these containers and how much CPU and memory power and processing overhead can they consume. The interesting thing about containers is they're comprised of images, layers of images, where each layer really only is a specific dependency for the application. These containers, when they run, they're built from images, and I'll show you a picture in a moment, but they really contain the application and the dependencies necessary to run the application. They do not carry all of the extra things that would be around, the extra artifacts that would be around in a conventional guest or virtualization instance you would find with a virtual machine. They're very lightweight, and they're efficient, and they're portable for that reason, and they become transient. You can fire them up and take them out very quickly, and they're very interesting for building microservices based on them. The Docker engine, which is the most popular, builds an entire system around the idea of containers, and I'm sure most folks have heard about it, but we'll talk about it a little bit. And the idea there is one of the advantages is decreased footprint. If you don't have all of the extra things in an environment, you only have the application and its dependencies, then you would think that to be naturally more secure, because you don't have the things that are there that can be exploitable. You have this reduced code footprint. And they become interesting. They're not necessarily a new idea either. They really are an iteration on, it's been around for a long time, the idea of BSD jails and Unix chroot. Those ideas have been around for a while. So it's just an interesting use of them, the way that we're using them today. So, and for several years now. I mean, they're not new by any stretch, but the ideas continue to evolve. So here it is. This is really the foundational idea. On the left, you see this server is your physical hardware. You might have a host OS with a hosted hypervisor. This would be something like Microsoft Windows Server or something like Hyper-V that provides a virtualization platform for which you can define full guest OSs. So this might be Windows 10 with some amount of memory and hard drive space allocated to it as a virtualized machine definition. And then within that, all the applications that you're used to seeing, scores of them. Or you could have a type 1 hypervisor here, where type 1 hypervisor is what they refer to as type 1 or bare metal, and it sits right on the server and abstracts the underlying hardware. So you could do some of these kinds of things without the guest OS in the middle. What you have here, the difference between running applications in a guest OS and running them in containers, is this idea of a very thin Docker management engine or a platform that provides kind of more of an ecosystem for container management. That's what Docker provides. And again, all you have here are, you see these little layers, the little orange and the little yellow slots here. These really represent the library dependencies, the things that are required to run a specific application. So you don't have an entire heavyweight guest OS, making these guys over on the right, the containers, very easy to spin up and tear down, and as a result, move around to distribute the applications and to deploy them. This tooling maps on to, if it's used the right way, it fits the bill for a lot of the DevOps ideas in terms of how you provision systems and get them in the various environments. You can build complete environments and allow them to be portable and shareable and reproducible, and it's very interesting for those reasons. And there's a lot of tools in play right now to spin on these orchestration tools and things like Kubernetes, and I'll try to talk about a little bit of that, but it can get complex and convoluted in terms of sorting out what goes where and when. Okay, so a little bit on images and layers. As I mentioned, containers are built from these images. You can think of an image like a program that sits on your computer, and when you run that program, you get a process. Well, when you run an application, what you end up with is a series of these layers where the application fits in a layer, and there's a number of these dependent libraries or components that the application requires to run. So let's say, for instance, you are over here on the right, let's say you're a Java person and you're running Apache Tomcat, and I don't know, Java or something underneath that Tomcat depends on or Apache depends on changes. The only thing that's required is the layer that represents that change. So when you're distributing the application or deploying it, you don't have this case where you have to move the entire application around. The way that these guys work, the images and the layers are such that only the parts of the system that change need to be updated in order to reflect that change. It makes it very interesting for distribution and deployment. I'm going to get into it in a moment. I was going to get more into the architecture, but the way it generally works is you want to run some application, and an application sits in a registry somewhere, either your own or the public registry. You make a reference, or you run the command that references that container image. The image, if it's not already locally downloaded, is pulled down with a very Git-like syntax, and it's run locally in the context of the machine. Nothing is installed on your machine, but the container, which the bottom layer contains an OS image, like the bottom layer might be an Ubuntu image with just a few dependencies to run some application. So what happens is it pulls these down, and it pulls down only the ones it doesn't have locally, and it maps a thin read-write layer on top of all that, so you can interact with it, mapping a terminal and standard input and standard output and run applications, and then it dies. So any changes that you make to it, unless you persist them, they're gone. So an interesting thing to do that people have done is, instead of explicitly installing software on the host, as an example, I can represent my applications as containers and allow them to persist only my data, for instance. So, very common thing that people that run Linux or Unix tend to do. So with that in mind, let's move on to some of the larger ideas that use that. It's important to have a foundation for folks that weren't sure about containers. So here's more of the idea, this idea of layered images, the bottom being, an operating system image, and then the various and sundry images, and then the top image being the image that the user interacts with. And you can commit this back, and you can do some things. The stack on the right kind of illustrates how that might look for a given system or application. These slides will be available if you want to peruse them later on. So what's Docker? And really, Docker is a platform for managing all of this, developing, shipping, running applications using container technology. It's really consistent in four components. There's a server component or a daemon component that sits local on the machine that is used to serve up commands or orchestrate commands. It has with it a RESTful command line interface for facilitating the use of those commands. It's a client to the server that does a lot of the heavy lifting. There's a registry, the public registry. You can create an account on Docker Hub, and it's kind of like GitHub, I guess, if you want to think about it that way, where you can have your own space, you can point your own images, and all somebody has to do, you make your registry private or public and whatnot, and all somebody has to do is make a reference to your image, and they can pull them. You can share your image very conveniently and very rapidly. So this idea of shipping and deploying your organization, of course, could have their own private registry. But these four pieces are essentially the components that make up this platform, which continues to become very interesting. There's some follow-on components to this that I haven't mentioned yet, Docker Swarm and Docker Compose, or composing entire infrastructures with Docker on top of container technology, and it works with Swarm. Swarm is this idea of managing large numbers of Docker hosts, so hosts that run the Docker daemon and can do Docker kinds of things in a single entity, and it'll handle load balancing and I'm going to talk about that. So I'll just move on. I think there's a slide on that later on. So just important to realize, we've hit this, it's not a virtual machine. It runs in the context of the kernel in isolation, and you can see the foundational differences in this picture. Underneath a lot of these slides are the references to where I pull some of this information, so you can go, if there's something that's interesting, you should be able to go back in most cases and get where I got it from and get some more detail on it. So benefits and risks. You got to ask the question, what's the good news? What's the bad news? Well, the benefits first, they're flexible. Even the most complex applications can be containerized. They're lightweight. They run the context and share a kernel. They don't require heavyweight resources and virtual, full guest OS instances. They're interchangeable. We talked about that. You can, because of the layered idea with images, you can deploy updates and upgrades on the fly. They're very portable because you can very easily deploy them locally or in the cloud. You can run them anywhere where you can run Docker. It's generally Linux machines and Windows machines as well. Using Windows currently they have their own container model, but they also support The Linux container model, if you run the Docker 8, we're going to do some podcasts that run some of these up at some point in the future. And I talk about a little bit about that, but they actually run these up in Hyper-V under the hood. So it's not a true support for Linux containers, but nonetheless, you can do it in a seamless way. They're scalable, they're stackable. Security, how secure are containers is definitely the discussion. It's an ongoing discussion, and it really starts to get back to looking at the and sundry pieces of it. You have to really give consideration to the fact that the Docker registries are server-based components that are potentially exploitable. The intrinsic security of the operating system itself, the kernel, if that's compromisable, certainly there's a weakness. So the different pieces, the command line, the client, the RESTful client there for interacting, all those have to be considered. And really the thing is to pay attention to the common exposures, the exploits and exposures, vulnerabilities, and make sure you keep things patched on a regular basis. That's really the big idea there. But lots of people are looking at how to ensure that containers are more and more secure. One of the challenges is when you start to use these in more complex environments, it becomes very difficult to reason. I talked about earlier, reason across these boundaries, because you don't have visibility. The nice thing about abstractions is it hides details. The bad thing about it is it hides details, and it's great when you want to build software, but it becomes challenging when you're a security person. You're trying to reason about what's happening, and you can't see it. When you upload data into the cloud, into various zones, you don't necessarily know where your data is going. You can see in the user interface or what the command line interface tells you, but where is it really going when it leaves your system, your endpoint, where you no longer have control over it? It's interesting things that lots of people are talking about. So those are the benefits and risks at a real high level. There's lots more. You can look at the link that I have there. But basically, what the Docker folks say is essentially what I've said here about security. You can get into it in more detail. Okay, this was just an example scenario of how somebody might use, Docker containers in an application instance. Not critical that we look at that. So we just, when containers really took off a few years ago, we decided to have some fun with them and stretch them to see what we could do. And what we did is something that really exercised what they can do, but that's not necessarily what you'd want to do. We built some Docker containers with QEMU, which is a system emulator. And what we did, just briefly, is we were able to script this so that we had a full machine definition. So what kinds of virtualized network adapters and processor types, are these ARM-based? Are they Intel-based? What are they? So the machine definition, if you're familiar with QEMU, you can define these interesting, like your Android emulators are defined with QEMU, for instance. You can do a lot of that here. And then on top of that, you can define, images like copy on write images or whatever other kind of image formats in order to boot OSs and all that. So what we did is we dropped QEMU inside of one of these stacks. So we were using containers to run QEMU to run Windows hosts, and then we would, on the fly, change the network driver or change the resources and fire these things up, and you'd see the operating system respond to, oh, I found new hardware. And it was just a fun thing to do to kind of to flex containers to see what they could do, and it worked well. It worked very interesting, and it's not something you'd want to do, but it was interesting from the perspective of seeing what they can do. And this is more of the same. A lot of the networking way down into if you got the inception thing going on, where here's a virtualized instance within a virtualized instance within a virtualized instance, we worked out some of the networking kinds of things to make them talk with the outside world, and that's a lot of what the cloud providers are giving you under the hood, in a much more rigorous and formal way than what we did. But it was fun nonetheless to try to work out making how these would work in this context, and we did a little bit of this. We fired up some Linux and Windows kinds of things, and so that's kind of Docker. That's the idea behind containers and the fundamentals. What we didn't talk about is this idea of orchestration tools and microservices, which are components of the Docker family. Docker machine, if you look around, you'll see, here's the link to it. It's what's necessary to allow Docker to qualifiably manage a host so that you can do Docker kinds of things. Docker Compose is a neat one. It's a tool for defining and running multi-container applications. So again, you're getting into this idea as I'm going to deploy a fairly complex system. That system is based on a number of cooperative services that have different requirements and different dependencies. And when you get into how to start scripting environments or infrastructure configuration, that becomes an interesting thing. And Compose is really the Docker orchestration language, if you will, for how you start to define those. So you can see here, these look a lot like things like, these are YAML based. So YAML stands for yet another markup language. And there's a versioning component so that, as things evolve with Docker versions and whatnot, or Compose versions, a compatibility set that you're running against. There are services that you can define. In this case, it's kind of small to see. This is a web service that's composed of a given image that's defined in a repository. That repository's username and this repo is they're defined by their username and a tag, which gets at a specific version of an image that can be containerized. How many to deploy? So the number of replicas, I want this many instances of a given image. And then remember I talked about the C groups. Here's an interface to that, an orchestration interface to that. How many CPUs or how much memory should this consume? What ports should be exposed? And what this is doing is this is saying this is running on a host of sorts. So Docker runs on like a Linux host or a Windows host or something. And what you have to do in order to interact with it is you have to expose those internal running container ports to the ports on the desktop. That's what you see here. So it basically says when you're from the outside, when you're coming in, this should be mapped to port 80 for this process running on your desktop. So web servers kinds of things. Networks, you can define complete networks. So they're defining, you don't see a lot of the details here, but this is saying that this belongs to a WebNet network, which is defined in another place. This also, here's a visualizer, which is another component. So a web and a visualizer, two different service components. So this becomes the orchestration environment by which you compose some of these complete environments. In this case, it's targeting deploying applications as microservices. And these can run in clouds as well. This can run, so you're going to start generally with some infrastructure, virtual machine nodes or whatever they're provisioned, or you can use this in something like heat templates, which are part of OpenStack, to target an infrastructure as a service, where you just take these instances of scriptable infrastructure or infrastructure as code, and you use them to populate your environment in different contexts, maybe for developers or maybe for a mock production environment. But the interesting thing about this is, because this this is a formalization of the entire environment, it really takes everybody to put it together. You have to know what ports fit the constraints for the production environment. Security and operations people know that. What protocols can be used? What are your firewall policies? What ports are generally open and things of that nature? So in order to produce something like this, it takes everybody in the organization that's in the path of the software development lifecycle. So it takes developers. These are tools that help people to work together to fit some of those things that we're talking about, where DevOps maps onto the various infrastructure as code, automation. This kind of fits the bill for a number of those tenets, if you will. So and that's really the DevOps model when you start to look at some of these things. This is the basis for establishing environment parity, and then how you make other processes for getting things into those environments uniform, process parity, So Swarm, as I mentioned, is a component of the Docker engine suite that says you've got a number of different hosts, and we want to be able to manage them as if they were a singular host, so that as a tool like Compose wants to start up multiple instances of containers to form your microservice, this guy is going to decouple the issue of, where does it go? Where should it be from a resource or an efficiency perspective? How does it get scaled, or load balancing? If you've got lots of things going on to service lots of different customer systems in a production environment, you want to load balance. You want to make sure that resources are being used efficiently. You want to make sure they're secure. You want to make sure you can roll updates in a timely fashion. Swarm is a partition component that allows that to be handled as a separate component, compose and swarm and machine. These things work together to give you some of that ecosystem to make all this happen in interesting ways. Cloud orchestration, as I mentioned, it's another level up. OpenStack is traditionally, it's kind of the leading source on premises or a private cloud solution, what's often referred to as an infrastructure solution. So it's concerned with allowing the user to compose and define all of the infrastructure. So virtual machines, network links, the kinds of information that can move across those network links. And it's a cooperative service model. It has the components in there for how you define what the hypervisor does and how it works. There are components in there for block storage. How does information persist in the form of virtual machine images or whatnot? Object storage. How are things persisted for long periods of time? All the kinds of things that are necessary to allow managing infrastructure are in there. One of the interesting things is the heat environment. Heat is the orchestration environment for defining infrastructure. I'm going to show you an instance of that. And they work well with other tools that overlap and share some of that functionality. In configuration tools, configuration management tools like Puppet and Chef, and also Docker, Compose, and Swarm. And interestingly, I haven't followed it recently, but if you look at some of the bigger guys like Amazon, AWS, the CloudFormation API, it's very much similar to the Heat model, if you will, the template model. There's even some portability or some compatibility between the two, so that if you take a Heat template, I'm going to show you one in a minute, and you point it at AWS, AWS will provide a heck of a lot more than the OpenStack primitives are. But if you fit that subset, you can potentially achieve some portable infrastructure across cloud providers. That's not uncommon at all. I haven't followed this so much. We were playing with it a while back, but very, very interesting, flexible, and powerful ways to achieve system deployments and some of these things that are leading edge. Here's the idea. You can't see this, but what this represents here, this text on the left, is a Heat template which defines lots of different resources, like and I think in this case, a number of servers that would run. One runs a database, one runs a web server component with I forget exactly which one it is in this instance. I think it's WordPress or something like that. And this is a Unix script, a Unix shell script here that provisions. It runs and it provisions all of the runtime environments, the Java environments, and all the things that are necessary to run a web site environment with a database and like MySQL and WordPress or something, all within this idea of orchestration with Heat. And so basically what happens is this targets the OpenStack Heat service, which isn't shown here, and that'll result in this virtualized infrastructure. But within that virtualized infrastructure, you can have tools like Chef and Puppet or Docker tooling that will allow you to compose lots of applications on top of this ultimate virtualized infrastructure as microservices. And what you see is this, the templates and the parameters, so the user can specify things to parameterize these templates, which define your basic infrastructure. There's environmental things that can be fed in that define the difference across different environments. So if you have a production environment or a testing environment, what are the IP ranges and whatnot, you can conform or configure some of the environment specifics. So that'll hit the Heat CLI, the Heat command line interface, which runs here, and the API, and it'll generate this virtualized infrastructure on top of the Heat engine. It generates it. So within that, you can do lots of interesting things. You end up with complete environments that look like this. This isn't so uncommon today, but all of the and sundry layers here, the abstraction service boundary layers, for ultimately how you get microservices to work within a virtualized environment like this. Wow. I mean, it's really cool, really powerful, but how do you reason across all these boundaries? How do you reason effectively about them when things go wrong? Really, the interesting thing is the management part of it, or the orchestration part of it. Things are great when things work well, but what happens when they go wrong or when you just don't have visibility in need? And I don't have the answer to that right now. I don't. But these are interesting conversations that people are having. This is an older picture. It's just one sense for what the strata might look like for a container ecosystem. You've got virtualized infrastructure. We've looked at that, things like VMware and OpenStack and Amazon EC2. This is Amazon's version of an infrastructure, lots of things in here. Operating systems of various sorts, container engines like Docker, scheduling and orchestration like Google's Kubernetes, Docker Swarm would fit in here. Workflow management kinds of things. This is older, but it gives you the idea. So you got all these service boundaries. This is where the end user tends to operate up here. All this stuff's happening all the way down here. How do you reason? How do you see across these boundaries? Interesting questions. And, that's things that are currently in the works right now in the community, smart people that are figuring out. More of the same, just a little bit on microservices and orchestration. And lastly here, I don't have a lot of time for this, unfortunately. I don't think I do. There's some very interesting things that go on within the .NET community. I just want to point them out if I can briefly. The .NET framework is the traditional .NET heavyweight framework that sits on Windows-only hosts. Interesting environments, development environments like WPF and WCF for Windows, desktop client application development and communication foundation for building distributed systems. The .NET Core is really cool because it's cross-platform. It runs natively on Linux, Windows, and Mac OS. The current version is in 2.2. It natively supports things like microservices and DevOps. It works with other tooling that allow it to plug right into DevOps pipelines and to build code natively that plugs into these things. And that's why it's so cool. Universal Windows Platform is another iteration of the stack that allows you to target, tablets and IoT, or also the .NET Core maps to IoT kinds of things as well. But this is more of game consoles and phones that are Windows-based. The other one is Xamarin, which is very interesting. There's two forms of Xamarin. This isn't so DevOps-y like, but it's part of the .NET family. Xamarin Native will allow you to, it basically wraps the native environments for Android and Mac OS. It uses a Java native interface to natively wrap those. So when you're building Xamarin Native, you're essentially building and dealing with Java code or Objective-C Swift code, but you're doing it all from within a single paradigm, the C# paradigm. So you get lots of reuse there. If you're going to build an app for Android or for Mac, you don't have different paradigms, different build tools. All those things are nicely managed by wrapping those native interfaces and making them available through a common paradigm, C#. And then there's Xamarin Forms, which is the other version. That's an abstraction layer on top of the Xamarin natives. It allows you to really build portable code now that you really 90-95% portable code. Only the things that are absolutely platform specific do you have to build in a platform specific way. And even those, there's Xamarin Essentials, which are managing a lot of that in a platform dependent way, and also things like dependency injection and the kinds of things you do with the dependency services that let you conform to using interfaces and object factories if you're an object-oriented design person to really take advantage of platform-specific code in a platform-independent way. Very, very powerful design ideas that are put in here, and that's why I like it so much. The .NET standard is very interesting because it's a formal subset, API subset, that's implemented by, let's see if I have a picture of it here, that's implemented by all the frameworks. So if you can build components that conform to the standard, they'll run anywhere on Windows, they'll run on Linux or Mac, and they'll run on the mobile environment. So you get this really nice way of building portable code that way. And this is not a trick or a hack. This is a standard or what's the word I'm looking for? It's a formal API specification that these other frameworks implement. I wish I had more time to get into it. So this is the idea. You can look at these slides. This is the traditional Xamarin. This is the shared code, Xamarin Native versus Xamarin Forms. And this is what's going on with the Xamarin architecture. You really do have the Android runtime as an example with the Android components, and you have the Mono environment, which is an open source version of .NET that's being used to power the Android native model. And what you have is Mono callable wrappers and Android callable wrappers that are using Java native interface to absolutely make this code natively available. in the C# or the .NET environment. So what you're dealing with as the code that comes out is Android code. You can consume Java libraries natively, and I think that's a really neat idea. So, and I think we're getting to the end here. So we're talking a little bit about .NET Core. I think I already did. We're running out of time here. Again, it's cross-platform. It's designed. Visual Studio tools are coming out now that will immediately let you take an application that you're building in the IDE and target it to like compose. If you want to compose an entire environment that we saw, Visual Studio is coming out with tools that allow you to take the development and go right to a complete environment with your code and all that. It's quite interesting. NuGet is a very interesting package manager that allows you to publish and consume code directly to Azure DevOps, the Microsoft model for, different people have different ideas on some of the Microsoft tooling. I totally get that. But the architectural ideas are very interesting and very powerful. And they're worth looking at, if nothing else, to learn from. This CLI is a complete orchestration environment, this .NET Core CLI for how you build and compose systems and push them around. It's designed to work with NuGet, and it's a native client of NuGet, actually. And what NuGet does, I think I've got a picture of it here. Let me skip right to the picture. But what it is, these are, so really what a package is, it's a managed assembly. A DLL is a managed assembly with all the metadata necessary to allow a client to consume it, okay? And it's really, it has the convention is it has a NuGet extension, which is really just DLL, managed code, with a descriptive manifest, the metadata needed to consume it and use it, zipped up and made available through NuGet. NuGet is doing some interesting things. It's using that metadata to do for us dependency management. So if you move code around and you're using NuGet, then the first thing that happens is NuGet issues a restore, which is a client call on, .NET CLI issues a restore to the NuGet repository, either public or private, and you can see what goes on here. And it'll pull down your code and all the dependencies. So dependency management is a huge thing, and it does that very well. So the creator can package, build, and publish, and then consumers that are defining their projects can consume these in a very uniform way. And there's a source here where you can go and read about it and get some ideas. I think this is chopped off when it was converted for the webinar, but the folks that are going to post it are going to clean that up for us. And that's really about it, folks. This is more on the basic process, and we're a little over time, so I'm going to, this just says that Visual Studio has lots of tools that support Docker natively now. There's some very interesting things going on with some of the IDE levels. And the good news is it automates a lot of this for you. The bad news is it automates a lot of it for you. So it really makes sense to dig in under the covers and make sense out of what it's doing before you invest in too much of the tooling. Microsoft's very good at providing you wizards that generate lots of neat stuff, and you have no idea what it did. So that's, in my opinion, that's a drawback. So anyway, next up, we're going to look to demonstrate some of these things. I don't have a time or a date on any of these, but we're going to look to demonstrate the use of basic Docker ideas in Windows and in Linux, some of the things that we talked about today. We're going to talk about how to run GUI applications. So, and how do you run something like an IDE in like Eclipse in Windows in a Linux container so that only your data persists, and how do you configure X server and all those things so that the GUI can work properly. We're going to do one of those. And the next one we'll look to do a demonstration of, probably number 3 would come first. These are out of order. Discuss the Docker tooling for actually demonstrating how you do compose a complete environment and how you might deploy it. How would you represent a build or a development environment versus a mock production environment, and how do you get the artifacts into that? That'd be an interesting thing. Some of our guys are looking at how to do some of that. And then another one with some of the things I just mentioned. How does .NET Core with the Visual Studio tooling support some of these kinds of things? How do you automatically deploy applications and containers with complete infrastructures in mind, and how are they portable? What are some of the challenges, and so on and so forth. And that is it. With that, there's some sources here. Thank you all for listening. I've said a lot, and I invite you, if there's anything in there that I said that was interesting, to go back over the slides, and I just hope it's been beneficial to everybody here in some way. So with that, I'll turn it back over to Steve, and we'll go from there. Steve?
Okay, Mike, thank you very much. That was a
Certainly.
that was a very impressive presentation, an excellent overview. There's a lot of stuff out there, and you gave us a nice overview of some of the things that are available. So we are running a little bit long today, but so what I will suggest is that if anybody has any questions for Mike on the presentation, or once we post it up there, if you take a look at it and you have some questions, on the CSIAC.org website, we have our technical forums. We have the one of the four main domains is software engineering. If you want to, if you have a question, get onto our tech forum and post the question, and we'll run it by Mike and see if he can get you an answer, or provide you some direction, a pointer to find the answer, or dive a little bit deeper into it. And as Mike mentioned, he is going to be doing some video podcast for us, where he will be demonstrating some of these capabilities, these techniques, and so once again, if you have some questions, he may be able to also incorporate that into some of the answers into his video podcast that he'll be doing for us in the future. So So I think that's a good place to stop for now, wrap up today, and like I said, thanks to Mike, and thanks to everybody for joining us today on the webinar. We appreciate that. And Mike, any closing words?
Yes, I would just thank everybody for sharing the lunch hour with me. I appreciate everybody listening to me, and I hope that there was something that you took away that you hadn't thought of before. So thanks very much. Have a great day.
Okay. Thanks, Mike. And once again, thanks to our attendees, and we look forward to hearing from you, and hope you join us for our webinar next month. We're hoping to have folks from the NSA. They have an initiative they call the Science of Security, and we're hoping to have the folks that lead up that initiative join us and tell us about that activity. And like I said, we're still trying to nail down a date, time with them, but we'll as soon as we get confirmation, we'll get that word out to you. So thanks again. Have a great day, and we'll see you in the future. Bye bye now.